All right, welcome back. So today we're going to be programming our potentiometer, our knob, to control a servo motor. So first things first, let's just get a sketch created. So I'm going to come here to create new sketch. At the top up here, I'm going to rename this sketch potentiometer and servo. So I'm going to rename this sketch up here, and I'm going to call this potentiometer and servo. Potentiometer is kind of hard to spell. It is phonetic, Potentiometer, and servo, rename that. All right, I've got my thing set up here. I'm going to actually hide this for now. And, yep, let's just get started. So what pins are we using? Well, we're using, now we don't need to do the pin for the servo motor. We'll take care of that later. I'll show you that technique. And the only other pin we have is the input pin for the potentiometer. So we're going to do pin mode, and we're going to do, let's create a variable for the potentiometer pin, just in case we need it later. Let's call that pot pin. So pot for potentiometer, pin for its pin number is equal to, I think I used A5. If you used a different one, be sure to make it a different one. So creates a variable and gives it a starting value. So that's what that line of code does. I'm keeping this really generic. I'm not saying what it's creating because I want to reuse this comment over and over again. All right, so that gives me that. So the pin mode, I'm going to go pot pin here. And then comma, I want to set it to as an input pin. Okay. So it sets the function of the pin. All right, so now we know that it's working as an input pin. That's where we're going to read it on pin A5. Everything's all good. Let's open up a serial port. Let's just remember to do that right away. Serial.begin. And remember our default speed is 9600. You could change that speed. So this opens a serial connection between Arduino and your computer. Right. Without this, you can't use the serial writes, or the serial prints, I should say. All right, I've cleaned up this too as well. I've got one indent here because they're both in the void setup. And now let's go out and do some reading. Now remember, we have two different ways to read. We can do an analog read, or we can do a digital read. A digital read means it can only read either whether it's on or off, so 5 volts or 0 volts. And for a knob, that wouldn't be very useful. We want to know exactly where the knob is. So in this case, we want to do an analog read. And that's going to give us a value anywhere between 0 and 1023, depending on what the voltage is. So if it's 5 volts, you get 1023. If it's 0 volts, you get 0. If it's 4.2 volts, you get like 800 and something. So now we can see there's 1,000 different positions that we can read on our knob. So to do that, we're going to use analog read. Make sure you have your R capitalized. And then here we need to say what pin we're in. So we're going to read the potentiometer. So we're going to use the pot pin for that. Analog read pot pin. And that's all we need for this one. We don't need anything else in these parentheses because we're reading something. We just got to tell it the location to read. So it's got to read the pot pin or A5. Now, Arduino stupid, it's going to completely forget that value right away. So we've got to give it a place to store it. So let's just call this pot val and put an equal sign. Remember what an equal sign is. It's not, doesn't mean equals. It means take whatever's on the right. So read the analog, read the value of the pot pin, get a number between 0 and 1023, then store that number in the variable called pot val. Now we haven't created the pot val variable, so let's do that next. Control C. This variable will be a whole number, so it'll be an integer, so we can go int, Control V, pot val, and equal to, let's give it a starting value of 0. And then I'm going to grab this sort of generic comment up here and put it right there as well. All right, now I need to put a comment on this code. So let's come down here and say, okay, so this reads the potentiometer and stores the value in a variable. Okay, and well, let's just do the name of the variable, pot valve. So reads the potentiometer in this part, so it tells how much voltage is coming from the potentiometer, and then it stores that value in pot valve. But let's just see if this is working. So let's go serial. Again, we can't see if it's working without printing something. Print. I'm going to use an ln on this because I want each one to be on a different row. And then I'm going to just serial print my pot valve. Semicolon, and this prints the value in pot valve. Ooh, pot valve on the screen. And yeah, let's see if this works. So I'm going to upload this code and see if I have any errors yet. Hey, look at that. No errors. So now I'm going to, once this goes dark green again, this arrow, I'm going to go serial monitor. And let's see what we're reading. 434. Well, that's a good sign. All right, so now let's rotate this to the left. And I'm getting higher and higher numbers up to almost 1023. And I just rotated that towards the positive side, the 5-volt side. So that makes sense. That's the highest number there. And when I rotate away from that positive side, I should be able to get down to nearly 0. So now the resistance inside the potentiometer is increasing. So now the resistance is so high, all the electrons' energy is being converted to heat inside the potentiometer. So they come through at 0. So now I can tell wherever I am on the knob, which is pretty cool. All right. So if yours isn't working, try and problem solve. It's probably a wiring thing. Check that first. Try and problem solve what's going on with it. All right, I'm going to put the screen away for now, and let's go do some more coding. We want to, let me fix this problem real quick. All right, so the next thing we want to do is we want to actually put the servo motor in. Our potentiometer is working, and now we just need to do a servo motor. To do that, we need to come up here, and at the very top, even above these comments up here, I'm going to open up some space, and then I'm going to come over here to my library. So it looks like a bunch of books next to each other. And I'm going to search for a library called Servo. What a library is a bunch of code someone else has written to do a specific task. Servo motors are really used all the time. So people have created code that allows you to easily work with servo motors. So I'm going to come here, I'm going to find the servo one and click include. Notice how the library is included right here. They put this line of code in for me. So now I have the servo library and all the code that goes with it. I'm going to go ahead and delete some of this extra space up here. And I'm going to delete these actually first comment here. We probably shouldn't, but I'm going to. All right. So if I want to look at what information is in the servo library, what I can use, I can click on the more information here. And it will take you to the documentation for that library. It'll just take a second to do the load, which is weirdly slow. And here are the different methods or functions. They're called methods, the things that you can do. There's an attach command, and it describes how to use that attach command. That's how you actually tell the library where the motor is attached. There's a write command, which is what we'll be using. This is where you write a certain angle. You tell it what angle to sweep to, so 90 degrees, 180, 270, whatever it is. Write microseconds, we'll use that later. It's for a different kind of motor. Read. So this is going to tell you what angle the servo motor is at. So if you want to know where it's at, you could do a read command, which is kind of cool. Attached. Will tell you where the servo is attached, false otherwise. So this is just confirming whether the servo is actually attached or you've used that attach command. We won't use that one. And detach will be to erase the current attachment. We won't use that one. We're going to use attach to attach our motor, and then we're going to also use the write command. So for the attach, we need to say servo.attach, and then the pin number. And then we don't need to worry about this min-max part. We can just do pin. This is if you want more control over it. And here's how it would look. So in the void setup, we'll do the name of the servo.attach. And up here, we'll name our servo motor on this like line 3. So servo space my servo outside the void setup. All right, so if you ever forget how to do something, the libraries are super useful. Let's get back and actually code this thing. All right, so up here above the setup, this library requires you to name the servo. So you do a capital S servo, space, and you got to name your servo. You can name it whatever you want. I'm going to call mine Haza servo, just so you can see you can name it whatever you want. What I'm going to do now is have to be careful to use this exact name when I use stuff in the future. Next thing I want to do is, just like the pin mode function for the potentiometer, we need to do an attach. So we're going to do capital S servo dot attach, parentheses, and then I'm going to do, oops, not capital servo here, sorry. You need to do your name of your servo here. Once we created the name of the servo, now that's what we're going to use for the rest of our code. So Haza servo dot attach, and then I need to have a pin number for it. So I'm going to come up here and create a variable servo pin. I'm going to keep that first S lowercase actually. Servo pin, and I'm going to do this as, I have mine in pin 3, I believe. Yep, pin 3. And then copy and paste this comment down. And then so Haza servo dot attach, and then that's going to be servo pin. We're going to copy and paste that down, put a semicolon. So this tells the servo library what pin the servo is connected to. Awesome. So far, so good. I'm going to close my libraries tab. I don't need that anymore. And now we need to use it. So if I go back to the documentation, I can look at the write command. And so here it says what you need to do is have the attach, and then have a my servo, so the name of your servo dot write, and then the angle you want to write it to. Okay, so let's try that out. So down here, I'm going to say Haza servo. You've named yours whatever you want to name it. And then I'm going to do dot write. And then whatever angle I put in here, it's going to rotate to that angle. So I'm going to put a semicolon here. And I don't know if my servos are usually 0 to 180 or 0 to 270. So we're going to play around with these numbers some. But what I want to do actually is take the value for the potentiometer and turn the servo to that value. So if I'm way left, the servo goes up. It just mimics my movement. So this actually sends the angle value to the servo motor. Wow, that was some bad typing. Angle value to the servo motor. All right. So before we get to this point where we're writing, what we're going to put here is we need to take the values. If I just take pop val and I throw it in here, it's going to send values from 0 to 1023, which is way more than 180 or 270. It's too big a number. It's not the right range of numbers. So this happens a lot in Arduino and in programming, is you have a measurement from some input device like a knob or something that's in the wrong range of numbers. There's a really fast way to fix that. So it's called the map command. So MAP. And what we're going to do is we're going to take the value of 0 to 1023 and we're going to map it down to a smaller value of 0 to 270. So we're going to go map. And the way this works is you say what you're going to map. So the first thing we're going to do is put in this part, pop val. So this says, hey, we're mapping whatever value is in pop val. Then the next two digits you put in, or next two numbers you put in, are the range that pop valve's currently in. Currently, pop valve could be 0 up to 1023. So I do 0, comma, 1023. So that's the high and low value for this variable called pop valve. Then you put in what the range you want it to turn into. So in this case, I want it to go 0, and let's just try 270 to see if our motor spins that far. So 0,023 to 0,270, and then semicolon. And this converts the analog numbers into angles. All right. Now let's just talk about what this code does. So map is a function built into Arduino. It's going to take the value stored in pop valve, which can be as low as 0 and as high as 1023, and it squeezes those values into 0 and 270. So if the pop valve is at 1023, you're going to get 270. If it's at 1015, you're going to get like 267 or something. So it's going to do that mapping, that conversion down to numbers. Now again, Arduino is stupid and it's going to completely forget this, so we got to tell it where to store this. So back at the beginning here, we're going to say angle. Let's call this variable angle. Let's call it servo angle to make it more clear. Servo angle. And then an equal sign. Remember, equal means do the thing on the right and then store that value in the thing called on the left, servo angle. Now we haven't created this variable yet, so let's do that. I'm going to copy that. I'm going to come up here. Mapping creates an integer value, so if there's any decimals on it, it rounds those decimals away and then puts it in as an integer. So I'm going to do an integer value, and let's give it a starting value of 90 degrees. That should be like right in the middle-ish, I think. And then semicolon, and then slash slash. Whoops, I'm going to copy and paste this line up here, right to there. And then the thing I want to well, let's just see if this is working. So I'm going to take this serial print line right here and copy it down below my servo angle. Clean up the tabbing, so I'm going to indent over. And then maybe I'm going to put one more space inside there. And instead of serial printing my pop valve, delete, I'm going to actually want to serial print my servo angle instead. And then I'm going to comment out this. I'm going to do that by clicking on the line anywhere and doing control slash. This way I'm not printing the pop valve as well. I just want to print the servo angle at this point, and see if this is working. And yeah, rock and roll. Let's do it. So I'm going to upload this code, find any mistakes I've made so far. Oh, I knew I wouldn't be. Oh yeah, I haven't done this yet. So we haven't put a command in here yet. So I'm going to just do control slash to comment this out. We're not using it yet, so let's just comment it out for now. Let me reload that. I was almost excited I was going to get two uploads in a row with no errors. That would have been a first for me. All right. Hey, we're done. Waiting for this green arrow. Yep, now dark green again. I can open the serial monitor. Let me solve this problem real quick. Okay, so I've got that problem solved. Now let's take a look at, I'm going to turn the knob here, and let's see what happens. Oh, it's getting bigger, but that's what we were doing before. We should now max out at 270. Yep, that's all the way to the right. So it's working. So I'm mapping what should be 1023, and it's being mapped to 270. You can see how it works all the way around here. Awesome. So that part's working. We just need to do our one last step, which is turn this back on. So I'm going to control slash it back into existence. And then I'm going to take my servo angle. This is the angle I want it to rotate to. Control C, Control V. I'm going to send it in here. So whatever this servo angle value is up here, it's going to now come down here, and that's what it's going to rotate to. Let's see it go. Let's upload the code. At this point, I don't need the servo monitor because hopefully my servo motor will rotate. All right, looks like it did move. Now when I rotate the knob, oh, nice. I rotate the other way. Oh, yep. That's super fun. All right, hopefully yours is working. If not, problem solve some stuff, check wiring, and see what's working, not working. All right, best of luck to you, my friends.